We are now ready to begin our programming and machine the first operation. From our demo part print, you will see that we have a surface area of 6 inches positive and 6 inches negative to be machined. Our tool for this operation is a 1 inch diameter or 0.5 inch radius end mill. To define the surface milling operation, press the surface milling key. Whenever you see a square icon, use the half key to toggle through your different options. In this case, it allows us to change between bidirectional milling on X, bidirectional milling on Y, unidirectional milling on X, and unidirectional milling on Y. For this example, we will use bidirectional milling on X. Press Enter to continue. X1 is our starting point on the X-axis. In this case, it is minus 600 thousandths. Type minus 600 thousandths and press Enter to continue. Y1 is our starting point on the Y-axis. In this case, it is 0. Press Enter to continue. L is the length of the part along the X-axis. According to our drawing, it is 6 inches. Type 6 and press Enter to continue. H is the length along the part in the Y-axis. According to our drawing, this is minus 6 inches. Type minus 6 and press Enter to continue. E. This is the amount of tool overshoot beyond the program part perimeter edges. In this example, it is 600 thousandths of an inch. Type 0.6 and press Enter to continue. A is the rotation angle of the program part about the defined part 0. The value in this field must be entered in as decimal degrees if an inclination angle is to be applied. In our example, we'll be using a value of 0. Type 0, press Enter to continue. ZS. This is your Z safety distance. This is the amount your tool will be above your starting point before beginning its operation. In this example, we will be using a value of 1/4 of an inch. Type 0.25 and press Enter to continue. Z. This is the starting point on the Z-axis. In this example, we will be using a value of 0. Type 0, press Enter to continue. P. This is the total depth we will be removing off the surface of the material. In this example, we will be using a value of 10 thousandths of an inch. Type 0.01, press Enter to continue. I. This is the amount we will be removing off the surface of the material per pass. In this example, we will be using a value of 10 thousandths of an inch. Type 0.01 and press Enter to continue. FZ. This is the Z-axis plunging feed rate. This value is entered in inches per minute. In this example, we will be using a value of 25. Type 25 and press Enter to continue. Coolant. Use the half key to select if you want coolant off or coolant on during the machining process. Press Enter to continue. F. This is your rough machine feed rate. In this example, we are using a value of 12 inches per minute. Type 12, press Enter to continue. S. This is your spindle speed. In this example, we are using a value of 2500 RPM. Type 2500, press Enter to continue. Using the half key, select if you want spindle turning clockwise or counterclockwise. For this example, we will select clockwise. Press Enter to continue. T. Enter your selected tool number for this operation. In this example, we are using tool 1. Type 1, press Enter to continue. D. Enter your tool's offset number. In this example, we are using offset 1. Type 1 and press Enter to continue. Next is your milling step over field. To ensure clean cuts, type in a value less than the diameter of your selected tool. In this example, we are using 0.8 inches. Type 0.8 and press Enter to continue. In this example, we will not define a finish operation. It will be necessary to set the finish tool number and offset to 0 to skip this operation. Finally, cursor over to the last icon to select the corner you would like to begin milling on. To toggle between options, press the half key. In this example, we will be beginning in the upper left corner. Press Enter to continue. Before the execution of any part, we strongly recommend that you run the cycle in simulation mode. This will allow us to prove that we have programmed the cycle correctly. The following steps will guide you on how to set up graphics. Select the graphics icon key. Select Type of Graphics using the F1 key. Select Solid Graphics using the F7 key. Select Display Area using the F2 key. We want to define the actual dimensions of our part so we have an accurate representation on screen. In this example, our min on X is 0. Press the down arrow key after each value is given. Our max on X is 6. Y min is -6. Y max is 0. Z min is -2. Z max is 100 thousandths. Type 0.1 and press Enter key to confirm the dimensions and save. You will now see solid graphics on your screen that represent your workpiece. For safety reasons, turn down the feed rate to 0. Press cycle start and now turn up the feed rate to 10%. The CNC is now simulating the part being executed. If there are any errors in our operation, they will appear here. To speed up the graphic simulation, turn up the feed rate override. The operation is complete with no errors. Press Escape to go back one menu. We have confirmed our cycle is defined correctly. We can now execute the cycle or save it to a program. In our example, we will create a new part program to save our newly programmed surface milling operation.